Hey there. I am not here today, obviously, but I made you a video so that you can learn how to find slopes. So go ahead and find your table of contents. And today is November the 8th. This is Unit 3, Lesson 2, and today we are talking all about slope. So if you need to pause the video to get this down, go ahead and do that. Otherwise, go ahead and turn to a new page in your notes. All right. So today, once again, November the 8th, Unit 3, Lesson 2. Today's essential question, very simple. How do I calculate slope? And hopefully the sub gave you a handout. It has a few examples on it. And later on, while we're taking notes, we will cut those out and get them glued into our notebook. But for now, we are going to talk about what slope is. Slope is the way we measure the steepness of a line. So it is a measure of how steep a line is. The bigger the slope, the steeper the line. There are four basic categories of slope. So I'm going to just charge ahead, but keep in mind that anytime you need to, you're welcome to pause the video if you need to get down what I'm writing. So what I'd like you to do in your notes is create four just teeny tiny coordinate planes. They don't have to be beautiful. This is for the four different kinds of slope. And I'm going to use colors. If you'd like to grab some colored pencils out of the buckets, you're certainly welcome to. The first type of slope is when you have a line that goes up and to the right. So I'm going to write up and to the right. So this one, as we move to the right, it goes up. This is a positive slope. So we read graphs from left to right just like we read English from left to right. And the reason I know this is a positive slope is as I go from left to right, the slope goes up. That means it is positive. The next type of slope you might have would be this. And again, we read lines from left to right. So as we read this from left to right, our line is going down. So this is down as we go to the right. And this is a negative slope. There are two other types of slopes. I'm zooming through this because I think this is review. Getting more markers. Okay, so the next kind of slope is a horizontal line. This has a zero slope, a slope of 0. As we go to the right, it's not going up, it's not going down. So we call that a zero slope. Our last type of slope is a funky one. It's like this. As we move to the right along this line, it's sort of like the universe goes away, right? Like there's nothing here. There's no line for me to either go up or down or stay flat. The line, as I move to the right, just isn't even there anymore. This is a vertical line, and this is called an undefined slope. When a slope is undefined, we're dealing with something that's not a function, right? This line obviously fails the vertical line test. And so in this unit, we're mostly going to be dealing with these two categories of slope, but occasionally we will see these, and we'll kind of deal with them later. So we know that the steeper a line is, the bigger the slope, and we know that if it goes up and to the right, it's positive. If it goes down and to the right, it's negative. But there are times when we need to actually calculate the exact slope. So not just positive or negative, but like, what is it? Is it 2/3? Is it -1/4? And so we need to kind of talk about how to calculate it. M stands for slope. I do not know why. If you want to research that and get back to me, that would be cool. But we use M to stand for slope. And I'm sure you've heard this before, that slope equals rise over run. You're going to hear me say that a million times. Slope equals rise over run. We always run to the right every single time. And that's because we read lines from left to right. So it's really rise over run right, okay? So if we rise up, we're dealing with a positive slope. If we rise down, which is a funny way to say it, but then we're dealing with a negative slope. So if we have a beautiful graph, we could count this, right? We could think, okay, to get from one point to another, how much are we rising, how much are we running? And we could write that slope down. But sometimes we don't actually have a picture. We need to have a formula. And so this is called the slope formula. The rise, another way to think about it, is the change in y. Because on a graph, the y-axis is the rise. It's the up-down. And we divide that by the change in x, which is our horizontal movement. So I'm going to write this formula that I don't know if you've seen before, and it looks completely freaky, but we're going to practice it. Don't stress. Here's what it looks like. y2 minus y1. So this means if we have 2 points, we subtract the y's from each other, and that will give us the change in y, or the rise. And we divide that by x2 minus x1. This simply means the x from my second point minus the x from my first point. That will give us the change in x, which is the run. So this just means my second y, take away my first y, divided by my second x, take away my first x. So from there, we're going to just start doing some examples. So if you could find example 1, it looks kind of like this. I've already cut it out. I think I'm going to trim it a little bit more. But right now, what I would like for you all to do is just pause the video, get example 1 cut out, and get it glued into your notebook. And then when you're ready, you can go ahead and press play again. Okay. All right, example 1 looks like this. We are going to find the slope of this line. So the first thing that I would like for you to do is think about, is this slope going to be positive or negative? And hopefully you realized that this will have a positive slope, because as we read the graph from left to right, it's going up. So this will have a positive slope. But more than that, I want to know, what is the actual slope? And so to do that, because we have kind of a nice graph, I'm going to use the graph rather than the formula. And all I have to do is identify 2 points on the graph. So to do that, you have to be really careful, because you have to look for grid crossings. You have to find actual places where the line crosses at a perfect spot. And that happens there, and it happens there, 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 there. So there are lots of points here that I can work with. To find the slope from a graph, you want to choose 2 points that are kind of close together. So I think I'll use these 2. And what you're going to do is start at the leftmost point, because remember we read left to right, and you want to move from one point to the next. In this case, I have to go up and I have to go to the right. You always should be going to the right, okay? How far up are we going? Well, if we start here, we're going up 1, 2, up 2, and then right 1. So the slope here equals rise over run. The rise was positive because I went up. I went up 2, so the rise was 2, and the run was 1. So the slope is 2 over 1. Now, if you can simplify your answer, you always want to. So in this case, 2 over 1 is really just a division problem, 2 divided by 1, and 2 divided by 1 is 2. So the slope of this line is 2. Let's look at our next example. So once again, pause if you need to, whenever you need to get this down. I'm going to just run right ahead and do example 2. All right. So I do have a graph here, but it's really challenging for me to see exactly where the points cross the grid lines. And also notice my scale. Here I'm going by 5s and here I'm going by 5s, and that's going to complicate it a little bit if I try to use the graph to calculate my slope. So what I'm going to do here is use that slope formula. So let's write it down. y2 minus y1 over x2 minus x1. Go ahead and pause to get that down. And then the next thing I want to do is take these points that this example kindly gave me, and I'm going to write them down. So my first point is 50, 10. Please write that down. And my second point is 77, 25. Okay. Whenever you're using the slope formula, you must label your points. So here's what I mean. This point has an x and a y. So under it, I want you to actually write x, y. This point also has an x, y. X, y. We're not done. This is my first point, and so I'm going to put little baby 1s down here to show that it's my first point. This is my second point, so I'm going to put little baby 2s down here to show that it's my second point. Now I can plug into my formula. So I'm going to give myself a fraction bar, and I'm going to go ahead and start by writing down y2. So y2 comes first. I come over here. There's the y2. It's under the 25. So 25 is my second y, the y for my second point. The minus belongs in your formula. You must write it down. y1 means the y for my first point. So here's y1. The y for my first point is 10. Come to the bottom. x2 goes next. x2 is 77. The minus is part of the formula. You have to write it down. And then the last thing I write is x1. So I come over here to x1. That's a 50. I've plugged everything in, and now I just have to figure out what does this equal and what does this equal. So 25 minus 10, go ahead and think about what that is. And then 77 minus 50, go ahead and think about what that is. That's my slope. The slope here is 15/27, but this can be reduced. You should be able to do this without a calculator, so we're going to practice it now. This slope can be reduced. I know that because I can think of a number that can go into 15 and 27. So take a minute to think, what number goes into 15 and 27? And maybe you figured out that it's 3. So to reduce a fraction, you divide the numerator and the denominator by the same number. So we're going to divide them both by 3. 15 divided by 3 is 5. 27 divided by 3 is 9. So the slope here is 5/9. It is positive, and that makes sense because this line goes up as we move to the right. This is really, really challenging. We're going to do several more examples, so if you feel like I'm going too fast, just stick with me. Okay, flipping to a new page, we have just a couple more examples to do today. So we're going to do example 3 next. So if you want to go ahead and get that glued into your notes. And again, obviously, pause if you need to. So we're going to find the slope of this line, and we can of course use the slope formula. You can always use the slope formula, but it's really not necessary here. When you see a problem like this, a graph, the best thing to do is just to find 2 points, move from left to right, figure out the rise, figure out the run. So what I would like for you to do right now is actually see if you can figure out what the slope is on your own. You can go ahead and write off to the side, slope equals rise over run. And go ahead and see if you can tell me what you think the slope is and submit it, and then come back to see if you were right. So for this problem, as we go to the right, left to right, that's how we read lines, we can see that we're going to be going down. So first we consider the rise, which in this case would be negative because we're going down. So we're going down 1, 2, 3. So that would be -3. So when we go to fill out our slope, the rise is -3, and the run, 1, 2, to the right. So the run is 2. And that is our slope. The slope here is just -3 over 2. Simple, simple. There's really only one more example that we're going to do, and we're going to write it in. So example 4. A line goes through -5, 10, and 1, 14. So please take a minute and copy that down. We could graph these points, but it's kind of annoying. I don't really want to create a graph that goes all the way up to 14. And so for this one, I am going to use the slope formula. So I'd like you to go ahead and copy the slope formula down. M equals y2 minus y1 over x2 minus x1. And before we begin using this formula, it's critical that we go through and we label our points. So see if you can label your points xy, xy, point 1, and point 2. Go ahead and do that now. So we've got x and y in each point, xy, and then here again we have xy. This is point 1, so it gets little 1s. This is point 2, so it gets little 2s. And now we can plug into this formula. So I want you to put an equal sign and then a long fraction bar. y2. So looking over here, we find y2. It's our second y. It's 14. Next we put the minus. It's just part of the formula. And then we put y1. So y1 is 10. I want you to see if you can do the bottom on your own. How would you write x2 minus x1? So x2, that's the x for my second point. The minus is part of my formula. And then x1 over here is -5. You have to put the negative. This minus is part of the formula. We have to say it's minus -5. So that is going to be a little bit tricky. Let's do the subtraction. 14 minus 10 is 4. That means the rise is 4, which makes sense, right? We're going from 10 up to 14. And then for this down here, I don't know if you remember way back at the beginning of the year when we dealt with subtraction of negative numbers, I taught you something called keep, change, switch. Keep, change, switch. When you have two negatives in a row like that, they kind of cancel each other out, and it really just becomes an addition problem. So this is just 1 plus 5, and 1 plus 5 is 6. And again, that makes sense because we're going from -5 up to 1, and that's a difference of 6. So 4/6 is the slope. That can be reduced. So take a moment and see if you can figure out how to reduce that slope. I'm hoping you realized that both of these numbers can be divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So the slope here is 2/3. So I'm just going to talk really quickly through what you're going to do for the rest of class today. The sub should have given you this checklist, and it goes through everything you're going to be doing for the rest of class. So you're going to log into Google Classroom. This is the code. Austin and Braden were not here last class, so you will need that code. And then task 2 is to watch the video and take notes in your notebook. So there should be a link there on Google Classroom for you to get into Edpuzzle, and you're going to watch, oh, you've already watched the video. Obviously, this is the video. So you should have done those two things. For the rest of class, task 3 is to do S2. It's really important that you work on this first, S2. It's just finding slope of graphs. You need a score of 80 or higher. Once you're done with that, you'll move on to S3. So that's task 4, S3 until you get 70 or higher. Now S3 has a worksheet that goes with it, so it looks like this. There's an example done for you. S3 is when you find slope from 2 points, and I just have this here to help you keep your work organized. This is going to be collected and graded. So even if you only get through 6 of them, I still want you to turn this in so that I can see that you did some practice finding slope. So this goes along with S3. Once you're done with all of that, I want you working on page 3 in your homework packet. If you finish that, which I very much doubt, there are some other things for you to do. You're not going to finish all of these today, probably, but just work really hard and get as much done as you possibly can, and I will see you on Tuesday.